So once you graph that, you should get a linear function. So when you go over here to graph it, and remember, if you have tabs open, it's very helpful to clear everything out, so there's no confusion about which graph it wants. So negative 2x, and then plus 4. So you graph it, it should be linear. Now, in order to graph it on the paper, where they have given you a little graph here to put it on the paper, do Control T. Control T will allow you to pull up the table. So here's where you can pick your points that you want to use to graph. The highest you can pick is this one because of the little graph. It only goes up to like 7. So negative 1, 6 would be a good place to start. So you want to see some negatives. So on your paper, this one right here, let's go ahead and plot those points. So negative 1, 6 was one of them. 0, 4 was the next one. What was the next one? 1, 2, right? 1, 2. Quit making that sound. 2, 0 was the other one. So that's pretty much enough to see where the line is headed. So go ahead and take a straight edge. Like on the STAAR test, you can use your formula chart or the graph paper. Some people use their calculators, but make a straight line through those points. No, put it away. Y'all don't need your protractors. I said use either your calculator as a straight edge, or like on the STAAR test, you can use your formula chart. Because they don't allow you to use rulers and protractors on the STAAR. I don't want you to get used to like, well, where's my ruler, and then you don't know what to do. No, just use a straight edge. Like you can use, I see some people use their calculator as a straight edge, the edge of the calculator, or they'll use a piece of paper like the formula chart instead. Put it away like I asked you to, because I don't want you playing with it later. Put it away. Alright, so let's start with the first part. The first part is domain. So if they want the domain, what are they asking for? The x value. So right here, I want you to put the letter x next to the word domain. And I want you to look for the x-axis, because we need to look here to see what are going to be all the x numbers on this that we'll use. Now, is it going to start right here and end right here? No, because of what? Why won't it start here and end here? That's where my arrow is. Because it's continuing, it's an arrow. So some people might think that you're only going to use these, but really you're going to use all of the numbers on the number line. So that would be called all real numbers. So if it's got arrows, linear functions do have arrows on the end, then that means they'll continue in both directions. Now range is what? The y value. So now instead of looking from left to right, look at your y-axis. It runs like this. So is the lowest going to be here and the highest up here?
No.
No, because it continues. In other words, that continues in that direction, keeps going, and then that continues in that direction. So there's no limit to the y's either. You're going to use all of the y numbers in both directions, positive infinity to negative. So a way to represent that is all real numbers. Everything on that number line, fractions, decimals, positives, negatives. So put all real numbers. Now the next question wants to know, well, what would be the slope of this line? You can tell me what the slope would be, and how do you find it?
2, 1, 2.
Well, see, I already heard a lot of mistakes. I heard 2, then I heard 2 over 1. It's actually negative. And that's why we want you to use spreadsheet. Or we want you to do this. Okay? Because a lot of you make those mistakes. You put the y over, or the x over the y instead of the y over the x. Or you do the run or the rise instead of the rise over the run. Like, you make a lot of errors. So this is what I want you to do. To play it safe, especially on the STAAR, because that could be the one question that helps you pass or get commended. Go to Menu, Do this with me, because you need to train your brain. Like, go to menu, and go look under geometry. Under the geometry app, we do have slope in there. If you go to measurements, you'll see it right there under number 3. So if you don't know what the slope is, or you're not sure whether you did it correctly, because a lot of you make mistakes, click on that, and then go click on the line. And see that little number under your hand? You got to move it to like a blank space, and click again to drop it. And so what is it? A -2. So again, I heard 1/2, I heard 2, but it's a -2. So you need to be very careful with that. I would rather you do it that way than to do it rise over run, because some of you forget the negatives. You really do. We're trying to alleviate. Now, you could have looked at the equation also. Remember that that right there is your m, and that is your slope. And you could also, if they ask you for y-intercept, remember this is your b, and that's your y-intercept. So you could have also looked at the equation, those of you who remembered what to do. But -2, let's put an m right here. It's the m in the equation, it's a -2, and let's put the calculator steps. What were the steps? Very good, menu 833. So let's write them down right here next to it. Menu, just put an m for menu. 833. Because a lot of you tend to forget that you forget that that option is there. So play it safe, especially on a STAAR. Like, you need to make sure you don't make a mistake. What is rate of change? We know what slope is, but what is rate of change? What is rate of change? It's the same thing as what? As slope. These two are the exact same thing. It is the m in the formula. It's the way that the rise and run are changing. Or the rise, or like some people will say, like, it's the difference of the y's over the difference of the x. But it's your rate of change is your slope, guys. It's the same exact number. It's just another way to say slope. So on the STAAR test, sometimes they'll ask for slope, or they'll ask for rate of change, and it's the same thing. You still go to menu 833 for that one. Menu 83, but you just have to remember that it's slope. Like some of you, you need to put that in your brain right now, that rate of change and slope is the same thing. Okay? Now what about your x-intercept? How can we find that? Where on the graph will I identify my x-intercept? Where it crosses the x. So this point right here that we plotted, that right there, point to it with a little arrow and put x-intercept, that is your x-intercept. It's where your linear function crossed the x-axis, which was at 2, 0, right? The coordinates, the point. Now, on your calculator, is there an option there that will give us the x-intercept?
Yes.
What is it? We've done this before. Menu 6 1. Another word, Joanne, for x-intercept. Remember there were 4 names that meant the same thing. What were they? Zero. Well, that's how you remember it. Xerox, right? It was 0. Sometimes they call them roots, x-intercepts, and solutions. So if you notice, 0 is there because that's another word for x-intercept. So when they want the x-intercept, you need to remember that 0 is what they call it in the calculator. And look, there it is right there. Now another way you can do that, so let's write it that way first. Let's write it down. It was menu 6 1. There is another way you can do that. And I saw this done at math camp. So those of you who go to math camp, you learn new tricks. I learned this from one of the other teachers. They did menu. This is a new way, so please watch. Menu, they went to trace, and they went to number 1. And what they did was, this little tracer that I put on my line, you can scroll up and down that line using the arrows, and that's what they did. And right there, a little yellow sign pops up, and it's showing you that that's your 0, which is your x-intercept, and there's the coordinates for it. And you can do the same thing for the y-intercept. Watch. If you scroll up, a little yellow sign will pop up when you're at the y-intercept. So it's pretty nifty. Like, you can use menu 51 also. I really like using that one too. So let's put or 5-1. So the next one says 0. What does that mean? It's your x-intercept. Put a little arrow. It's the same thing as that word. It's the exact same spot. And so it would be the exact same point. So 2, 0, and we can use either menu 6-1, or we can use the trace, which is 5-1. And on your graph, let's put the word 0 underneath the word x-intercept, because that's what another name for the same thing. So there's 2 names for slope, and now we know there's 2 names here that mean the same thing. Now there's actually 4 for the x-intercept though. Like when we get to quadratics, these are the 4 they call it. Now the next one is y-intercept. What would be the y-intercept? It's where it crosses the y. So right there, let's put a little arrow showing that that is our y-intercept. And it is 0, 4. Write it as a coordinate. It is a point, so let's write it as a coordinate, 0, 4. Now, the b in the formula, if you go straight to this number that they add or subtract, that's your y-intercept too. Now, they just write it as 4. But it is a point, so you want to write it as 0, 4. But let's put a b right here so you remember that it is your b. Now, what would be the steps I could take to find it in the calculator? Like, what if I wanted to do it in the calculator? Menu 5-1. Do the trace. Remember? Right there. If you scroll off and then back on, look, there's a little yellow sign that shows you, oh, look, there's my y-intercept. So it does, you can use menu 51 for that one. So menu 5-1. So don't get those questions wrong. Look how many can be done in the calculator. Every single one except domain and range. So you want to make sure that you get those correct. Very simple problem. Alright, so let's look at the next one. What is the next one going to give us?
Quadratic.
Quadratic. What do those look like? Like a U. Okay, so let's type in this one. It's kind of like a U-shaped curve. So negative, they call it a parabola. So negative 2x squared plus 1. Let's see what our U looks like. Okay, it's upside down. Alright, so that's your quadratic. Let's graph it. Let's do Control T. And let's do some negatives. You always want to plot some negatives and some positives. So I think this is the highest you can go because of the graph that they give you. It's super small. It only goes up to 7. So, and it goes down 7 also. So let's start there. We're going to start right here. Negative 2, negative 7. So that one would go here. And then the next one is negative 1, negative 1. I'm just plotting those points right there. 0, 1 is the next one. And then 1, negative 1. And then there's a 2, negative 7. And then just draw your quadratic. It's like a U. Sometimes it's hard to draw. For sure it's hard to draw for me. I gotta look up on the screen. That doesn't work. Let me try that again. Okay, well that's the closest I can get it, guys. Sorry about that. A little weird. Alright, so anyway, what it looks like, let's start talking about the domain. What would the domain be? Because those are your x values. What is the domain? We're going to look at it from left to right. Does it stop here and here? No, because it expands. It gets wider. As it goes further and further, it keeps getting wider and wider. So those little lines would get pushed and pushed and pushed. So actually, you're going to use all of those numbers that are on that number line. So all real numbers. Now, what about the range, though? Because on the linear, it was all real numbers for both, but look at the range. What's the highest, what's the lowest it goes, and what's the highest it goes? The lowest it goes, there's no limit, right? It's not going to stop here, like it keeps going. But the highest it goes is right here.
1.
So at 1. So how could we describe that? Like if I wanted to describe what y numbers I'm going to use, how would I make like a little inequality?
1 is less than y greater than
No, we just need the numbers less than 1 and equal to 1. Equal to 1. That's it. Just a single inequality. We don't need a compound one. Compound is when we have two limits, like the lowest is here and the highest is here, and it's between both. If it's just going in one direction, then you just need a single inequality. So from here down, like if you had a highlighter, you could highlight that it's all the numbers from here down. So you're not going to use anything above that, okay? Alright, so how about, is it a min or a max?
Max.
It's a maximum, so circle max. Now, vertex means they want the coordinates for the max. Vertex is like maximum point. What's the maximum point?
1.
0, 1. Like write it as a coordinate. They want the maximum vertex. They want the highest point. So you have to write it as a coordinate. So 0, 1. Now on the calculator, do we have that option? Because let's do Control T. Is there something in there that says maximum?
Yep.
Where is it?
6.
Menu 6, 3. Right there it says the word maximum. If you don't know, look for it. It doesn't hurt for you to take some time to kind of say, well, you know what, maybe there's a maximum somewhere in there. So there's a maximum right there, and then you just click and drag over that. So there it is right there. So 0, 1. And let's put the steps. It's menu 6, 3. Now the next question is it a min or a max value? Well, it is a maximum, because we already said it was maximum vertex. But what is the difference between vertex and value? What does value mean? Well, the whole thing was the vertex, the point. What does value mean? I've said it before. It's only the y coordinate they're talking about when they want the maximum value, because they want the highest number it goes on the y-axis. So that would be 1. So the maximum value would be 1. Now, on your benchmark, I just want to do something real quick. Please listen, because a lot of you made this mistake, and we'll go see who made that mistake. On the benchmark, there was a question like that. And the question was, what is the maximum value? And a lot of you, like the point was 49. So what would have been the maximum value?
9.
The 9. A lot of you on your griddable, this is what you put, because it was a griddable question, you put 4.9. Because you were like, well, I know it's 4.9, so let me just put 4.9. Maybe that'll work. No, that's your vertex. So if they had said maximum vertex, then they would have had multiple choice to choose from. But since it was a griddable, you can only put one number on griddables, guys. You can't put two numbers. And, you know, 4.9 is definitely not the same as 4.9. What they wanted was the value. They only wanted that number. That's all you had to put in your griddable. So I think some of you kind of knew that it was up here, but you didn't understand that it was only the y number. So you need to be very careful with that. You would have gotten it right, but because of that, you missed it. So right here, let's put y coordinates. So that way you remember it's the y coordinate. And put a little arrow like off of this y coordinate here. So that way you remember that it is this number that they wanted. I don't know, highlight it or put a little arrow or something. Now the 0 is what? Where do I find my 0? On your x-axis. So like right here, there's one right there, and there's another one right here. So let's put a little arrow pointing to that one. Let's put a little arrow pointing to that one. And let's write 0. There's 2 of them. Now on your calculator, what are the steps? That way we can write the steps. Menu 61. It even says 0. Look, right there. Joanne, stay awake, please. Menu 61. So you need to make sure that you go to menu 61 when you want the 0. So click and drag. There's one of them. And then do the same thing. Menu 61. Click and drag. Do the other one. So there are 2 of them. Let me move that out of the way. It's negative 0.7 if we round it, and positive 0.7. So let's write the 2 down. So it's negative 0.7, comma 0. Write it as a point. and then positive 0.7, comma 0. And then the steps we took on the calculator were menu 61. Now the next question says x-intercept. Where would I find that? Same place as a 0. So it's the same answer. Like an x-intercept can be found where the graph crosses the x-axis, and that's where my 0 is too. So let's put the same answer. And let's put the same steps for the calculator, because those are the steps you can use. M61. What about roots? Same thing. Remember Xerox? You need to remember that word, and we'll write it down in a minute. But the roots are also in the same spot. It's where your graph crosses the x. So write down the same numbers. And put M61. And the calculator is called a 0, but if they ask you for a root, it's a 0. It's the same thing. And then solution. What about that one? It's the same thing. It's where your graph, your quadratic, crosses the x-axis. So that's a solution, and that's a solution. So let's put that number in there too. And let's put the same steps. So if they want the solution, guys, you can find the x-intercepts, and that would be the solution to your quadratic. Now what about y-intercept? It's where it crosses the y, and it actually happens to be the maximum vertex. It's not always the same, but on this graph here, it happens to be the same point as the maximum vertex. But don't think it's the same thing, please, not on that one. So this one is 0, 1. So look, it ended up being this. That number right there ended up being your y-intercept. It's kind of like mx plus b, but it's ax squared plus c. They use a c for it. Yeah. And then the last one, I know mine got cut off. It says what, axis of symmetry? So what is the axis of symmetry? What would be the equation of this line? Because that's your axis of symmetry. It's the line that splits it down the middle. Is there a way to find it on the calculator?
X equals 0.
Yeah, it is x equals 0, but is there a way to do that on the calculator?
Menu 6, 8, 4.
Very good. We've done this before. Menu 6. Everything is pretty much under 6 when it comes to quadratics. Go to number 8, and it's right there, axis of symmetry. And then all you do is click on the line. Like, you need to click on that line, and there it is right there, x equals 0. So that would be the equation for this axis of symmetry. It's the line that split it down the middle. So x equals 0. And right here, put menu 6, 8, 4. By the way, what would be the steps in the calculator for y-intercept? You could have done that in the calculator. You could have done trace. Remember, trace will get you the y-intercept, guys. It's that one right there. Look, 0, 1. And if you're not sure, look, move off of it and then go back and the little sign pops up. Look, and move off of it, go back, it says y-intercept. Look, I could even do the zeros that way. There's a 0 there, and there's a 0 there. So trace is also an option if you want. Alright, so the last one is on exponents. I wanted you to see an example of an exponential, because on the STAAR test they'll also test you on that. So let's graph 1 times 2 raised to the x power. Here's your raise key. This is what your exponential looks like. It's kind of like a curve that kind of starts here, leveled out, and then all of a sudden, boom, it just increases very rapidly. This could be like representing like viruses. In biology, you probably see a lot of graphs like that when they're talking about how quickly a virus is spreading, because they just multiply so quickly. And so that would be a good, kind of like in the real world, something that would be exponential. So now, let's see what the questions are that they're asking us. Well, let's graph it first. I guess we got to graph it first. Let's do a control T. Let's look at some negatives, just a couple of negatives. We can just start here at -2. So let's graph it, -2.25, and then -1.5. Let's see, what was another one? 0, 1, and 1, 2. So 0, 1, 1, 2, and let's do one more. We'll do 2, 4. So you can see how it starts. Kind of starts a little bit leveled, and then it all of a sudden just increases rapidly. Joey, make sure you're awake. Great. Guys, sit up. Like, this is for STAAR review. Some of you remember this stuff and some of you do not. And those of you who do not, like, this could be the make it or break it question. You know you need to pass, like, this. Who is this person? Oh, I remember. Never mind. But some of you could have been in here, guys. Look. You were in the green, but you could have been in the blue. And who are my blues? You could have been with them, because they probably remembered all those words. Like, you need to stay awake and train your brain to remember this stuff. A lot of it's in the calculator. Look at that. Alright, so let's look at domain. What would be the domain? All real numbers. Look, here are your x's. You're going to use all the x's that way, and because this gets wider and wider that way like this, it does get a little bit wider as it moves, it goes that way. So all real numbers. How about the range?
It's y squared under equal to 0.
It's not equal to, you almost had it, but you're right about the 0. It's all the numbers greater than 0. I'm going to show you something, because some people think this is actually going to touch the x-axis at 0, and it actually doesn't. And the way I can prove it to you, because one of my students in the other class, they thought it hit the 0 too, because they were like, look, it's touching. It really isn't. It's very close to it, and it looks like it is, but I guess the thickness of the line makes it look like it is, but it's not. And this is how I proved it to him. I said, look, let's do a trace. And so we put a little trace on it. And I said, okay, keep an eye on this number right here, right? Because we're trying to see who's going to hit 0, 0. And so we tried it. And we scrolled, and we scrolled, and we scrolled, and this number just kept getting smaller and smaller and smaller and smaller, and this never turned into 0. It got real small. Point, see, it's getting small, and then they start using even exponential notation, because the numbers are getting so small and small and small and small. And you can hold it down, like hold down the arrow in it, and just keep going and getting smaller, but it never crossed over or got to the 0. Never. It approaches 0, but it never got right on 0. So that's why you would not want to put the equal sign. Ooh, right there it says 0. No, but it's not supposed to. I went too far.
Hey, we did it. It's a 0.
No, it's finally, what happened is, it couldn't even fix this.
Man, you lied to me.
No, I'm not lying.
Man, it's just so bad.
I know it is.
Was it?
No, what happened is this, guys. It was so small, they're like, you know what? Just call it 0. Like, seriously. Seriously. Okay, let's look at the table and see if it says on there.
Watch it say 0.
Where was it that it said 0? In negative 48? It's because the number's so small that they're like, you know what, round it to 0. Even the calculator got tired of, like, it probably ran out of space. Like in that cell that is putting the numbers, it ran out of space. And so, look, it's not equal to 0. I don't know why it eventually rounded to 0, but it's not. So you can say that it's just greater than 0. Don't put the equal. Be careful with that. So when they ask you for the horizontal asymptote, I haven't explained this because it hadn't come up, but when they want that, they're asking you for that line right there where it doesn't cross over. So it's at 0. This is the horizontal asymptote. It's actually, in this case, the x-axis. So we can put here x-axis. That's our horizontal asymptote. And the equation for that would be y equals 0. Because look, if I graph this equation, you'll see that it draws the x-axis. So watch, I'll prove it to you. So again, let's do Control T. I'm gonna move that out of the way. Let me put the graph back on the way it was. By the way, Zoom Standard, like if you ever do the trace and you want to see the graph again, just go to Zoom Standard. So watch, when I hit Tab and I type in y equals 0, let me just put the 0 in there. See? It's the equation for the x-axis. And so that's sometimes what they want, the actual equation. So you could write x-axis and then put the equation. Now, vertical asymptote. Okay, that would be the vertical one, like this. And so this, though, keeps getting wider. So there is not one. Like, it will cross the next vertical line, and then it crosses the next vertical line, and then it crosses the next one. There's no limit on the vertical one. And again, you could use a calculator to help you. Like, you could do Manufy 1, and you could see and go in the opposite direction. Because look at these numbers right here. I want you to look at the x to see, does it ever, like, get close to, like, a specific number with math? Yeah. So look at the x number, 2.7, and then 3.3. Look, it just keeps getting wider and wider. So that one doesn't have a limit. There's not a limit, and we can check the table, too, to see if there's a limit there. So watch. Let's look at this number right here. So let's see if there's a limit. Let me hold it down. Is there a limit?
Hold it down.
No, there's no limit. Not on that one. So we can put none. Sometimes it only has like a horizontal, it doesn't have a vertical. So on this one, we'll just write, there is no limit. There is no line that it doesn't cross over. Like here, it was this line. But there's no line like this that it will not cross over. Alright, so that's it. That's all I wanted to cover today. Tomorrow we're going to do stations, and I'm going to give you graphs, either linear, quadratic, or exponential, and you'll have to answer questions about the graph. Keep that in your notes. You can put away your materials, but go back to your desk, please.